Hey everybody. So I want to start this video by talking about this research paper, Causal Interpretation of Self-Attention in Pre-trained Transformers by Intel Labs and by three researchers at Intel Labs. And it's a pretty good paper overall. It's essentially the gist of the paper is that supervised learning or unsupervised learning and like self-supervised learning as it's called, now like it's getting more and more called, is like good for LLM models, and is like the best way to like um, structure LLM models as a whole, and that you can apply that concept overall even to the transformer mechanism and the attention mechanism itself. And then so in this instance, what Intel calls it is like a causal interpretation. And then so like the ability to like make that connection, like that self connection, and then so through causal links, and then so they give some math problems, and then if you notice there's a source, I just want to point this out first of all as we're going through it. There's a source for every single one of the math problems that they lay out here, right? And so I think that's important, just highlighting that as we go through. Um, every single one. And then so as we go through the paper as well, then they give their essentially like attention based causal discovery ABCD. They give like some like and then like essentially like how they structure this out. They give the model of ABCD and then like their limitations of it, and then essentially explaining kind of like what it is as far as like self-attention for the transformer mechanism, and then for like pure attention algorithms, right? Like, and then they highlight it here very specifically. And then here's the GitHub, and then they have their GitHub release for it. And then we can go back to the paper there. But so they release it under an Apache license, under Causality Labs. Pretty cool stuff. And then they did release it on like a while ago. So this paper is like they've been working on this paper for a while. So I think that's one thing to highlight here. But going through they go through and then they have kind of like benchmarks for like their testing versus like other like uh, testing in this area. So I think like that's extreme. And this is where I want to go next with with this video, and I'm going to start here with this. Is that like so? There's like Intel Labs isn't the first ones to hit on this, right? Like this self-supervised learning concept and this self-learning concept. There's a lot of people around it, and then so I want to get more in depth into that. But let's first of all we'll focus on the paper here that we're looking at. And then so we go through and they produce some nice benchmarks of their approach compared to other approaches within this. And then you can see that they have like they literally build like abductive inference and causal discovery into the transformer mechanism itself. And then so if you're not totally familiar with these things, and either on the technical or the like logical level, essentially abductive reasoning is like generalized reasoning, like oftentimes abductive and inductive reasoning are grouped together because they kind of often are the same thing, where it's but like abductive is generally like more generalized, right? Like so like if I say that the ground is wet and I left my shoes outside, abductive reasoning would tell you that my shoes are going to be wet and because it like that generalized, and then you utilize causal discovery as the mechanism for that. That's how the human brain does that, right? And then so essentially what Intel's paper is like, hey, like let's take this concept of abductive inference and causal discovery and give it straight up to an LLM model, in this instance through the architecture itself, right? Like through the transformer architecture, through the attention mechanism. And then so the way that they utilize that, and they talk about that within their system, is their system that they call clean, and then with two ends, and then they get like benchmark and then some discussion, and then so now we come down to the references for the paper, and then so like the references, so like the first like 15 or so are like all like, or 20 are all like the mathematical equations, and and then so it's like all the these are all of the references for all of the mathematical equations, right? And they're all like old references, and then like the thing to reference that I want to point out here, like with the this particular paper here, is like this has a ton of references in it, right? Like it's like 48 references within this paper, which like on your first glance you'd be like, oh, that's like really like there's like a lot of uh, research behind this paper, but like if you look through this paper with the amount of reference it is like there's not a lot groundbreaking. Like there's nothing that like particularly new that Intel themselves are directly introducing with this paper. But this paper is going to get more attention in this area because it's released by Intel than any other research that's been done in this area. So that's why we start with this paper, right? Because it's what gets your attention is that it's the Intel paper. And then so just highlighting that overall. And then I do also want to highlight one author as well that they talk about very specifically, like within this paper, and it's a famous author on this particular subject, particularly on unsupervised learning, and it's Vishwal. And then I just want to mention that name, Vishwal, and then we'll come back to it in a second. But so as we go through to the other thing that pointing out is that their notations on this paper are really good. So I'll link to this paper in the description for the video, but the cool thing that I do like about this paper, and just calling it out, very nice job on Intel's side, is that they do give their all of the reasoning, and like they actually give like a way to reproduce this, right? Like, which is like my criticism a lot of these corporate papers. They don't give any way to like actually reproduce their research. They say, hey, we did these things, congratulations to us, like here's our big pat on the back, and then like no other way to like reproduce their actual results, right? And then so like with this Intel paper, it's like here's our algorithm, like here's the clean algorithm here, causal like explanations, and then here's like the functional algorithm, right? And so I can actually like cool, like thank you, and then they give their proofs, and so like actually like giving their reasoning behind the paper I think is important here, but so I don't know if it's coincidental or not. It's probably coincidental, right? But so the paper releases on October 31st, which is like the end of October, and then so to me like what I noticed within this is that like there's a lot of research within the last, I'd say like within the month of October, very specifically around this topic. Like so like again, like Intel's not the first one to go on these concepts, right? And these concepts are known, and like but Intel's always the biggest one. So like but so I'll just like the next thing I'll go over to is a paper that I released on October 27th, which is called Curiosity-Driven Autonomous Learning Framework, or CAF. Which is, so if you look at CAF, essentially new AI framework uses curiosity to explore environments without supervision. And then you break it down, and then I have my GitHub repository that we can go over to here, and then I call it unsupervised curiosity. Curiosity mechanism inspired by far curiosity, but for unsupervised learning. So again, like I'm building off of research here too, right? And then so I'm building off of a lot of like visual research, which is again bringing up that name, being honest with it, and like overall. So the what I lay out in my paper here is like very like similar in a lot of ways to the Intel research paper with regards towards unsupervised curiosity, or CAF, and what the Intel research paper is with regards towards causal interpretation of self-attention in pre-trained transformers. And then so the big thing that I want to talk about and highlight with this overall is the fact that I think it's the fact that like when people have the debate over whether or not like this should be like open source or like corporate involvement, things like that, like so if we didn't have, I think in my opinion, like multiple drivers of an impetus around these particular issues of collaboration, then I like so the Intel paper is great, right? Like I'm glad that this Intel paper comes out. It comes out at the very end of October, right? Like I'm just highlighting that overall, and like that's the kind of the argument that I want to get here is like the only criticism that I want to bring here, like, is, and not even a criticism, it's just a question that I want to ask here at the end is, would this paper exist if other papers around this issue didn't exist that kind of built upon and force Intel's hand on this issue? And like to me, I think that the answer is that this paper would not be released if papers like this weren't released. And I build off of research, off of my own paper, off of like lots of other research papers that aren't going to be talked about because of the Intel paper, and other papers and other advancements that I've been seeing like more and more around this specific issue, right? Like I didn't just predict, like I didn't just go have an epiphany out of nowhere to come up with like a curiosity-driven autonomous learning framework. Or like kind of like literally the exact same thing that Intel's drilling into with their paper, right? Like it's, I mean, research is research, and then so people are talking about these concepts. I'm thinking about the same things that other people are thinking about as you're going through this, and that's kind of how all of these things develop. But so if you don't have that, like if you're saying we're going to make that pie smaller, in what world is that good? Like that's kind of my uh, question that I would like to pose overall to this. Like imagine again, like a world where these things don't exist, where you don't have the lead up to the Intel paper, where all you have is the Intel paper. And then so if all you have is the Intel paper, then very quickly you're not going to have the Intel paper. And then so to me, it's not a battle of whether or not like open source research or like academic research in this instance is what open source research mostly is, primarily is with regards towards AI driven research, then as opposed to versus corporate research. I think it's more of a like cooperative scale, and both are needed within this system. And then so if one side, if you hear arguments that are advocating only for one side, I would question the interests of like that particular side overall as to like where exactly they're trying to come down on these equations. Because in what, like I don't, to me, again, like just the argument, like if these types of research did, and I released mine full MIT license, right? Like so, like anyone could utilize my. I'm like, I'm not trying to sell either one of these or anything like that, but like making the argument overall that like there's people that, and I'm not the only one, right? Like again, mine is built off of Far Curiosity, which like you should look up Far Curiosity as well, because Far Curiosity is like really cool with regards towards like reinforcement learning, and then reinforcement learning in this realm as well, right? Like, and so I can only assume that like, and Far Curiosity is what got my attention within this, is that like, well, like that's cool, like, but I think like you like as I'm starting to piece together that like more and more, I think the answer is unsupervised learning as opposed to like necessarily reinforcement. I think it's a mixture of all of the elements, right? But I think like the element that's been ignored is unsupervised learning, and then now it's we're seeing like a sub definition of unsupervised learning come about, which is like this self-supervised learning. So you have unsupervised learning, and then subcategory self-supervised learning, and then like I like that is the big area that we're talking about overall with this research. And I think it just, you know, like more and more is where we're going to see kind of the advancements in this area. So overall, that's my input on this paper. Again, I'll leave all of this in the description to the video. Hope you like this type of content, and please like and subscribe if you do. Thank you very much.